Hello everyone and welcome to this video. So in this video we are going to be learning the other way we can learn how to choose the right machine learning model. So we're going to be looking at how to choose a machine learning model for classification. So last time we did regression, now we're doing classification. So let's start. So here we are. This is where we left off last time. So we learned how to choose a right estimator, which is a model in Scikit-Learn. And then we learned how to do it for a regression problem, which is basically just estimating a number. But today we're going to be looking at a classification problem, which is up here, predicting whether a sample is one thing or another. Okay, so it's out of two things you have to predict one of them. So we put a link to the Scikit-Learn map. So we're going to look at that after we have set our title. So let's put our title up here. So we want markdown cell. So this is 2.2. So choosing an estimator for a classification problem. Okay, so yeah, let's enter that. And now we can go ahead and refer to our map. So this map is basically it's a mind map. Actually, it's a classification chart that allows you to so we have to start, and then follow these arrows, and they'll have conditions. So you either go yes or no, and then you'll find your machine learning model. So today we're going to be looking at classification, as I have told you. So yeah, so the first thing we're going to want to do is we're going to want to load our heart disease dataset, because that's the sort of dataset you'll want to use for classification. Okay, so let's actually refer to the map. So over here I'm going to write, let's go to the map, and then I can just copy the link. There we go. So yeah, so now that we have done that, what we can do is we can load our heart disease dataset. So we'll go heart disease is equal to pd dot read csv. So I have got in my data file I have got my heart disease .csv. Okay, so now that I've done that, let's view our heart disease file. So heart disease.head, because heart disease has a lot of lines. So these are the first 5 lines. So the target here, you can see that it is actually mostly ones. But let's say I view all of it. You will see that there are some zeros at the end as well. So it's either a 1 or a 0 when it comes to target. Whoops, heart disease dot head, not heart. There you go. So now that we have done that, let's just check the length of our heart disease dataset. So it's got 303 rows. So we'll just go to here now. So we're going to obviously start at the start button. So so this is sort of a reminder how to find your model. So the first thing we do is we start at the start button. Have we got over 50 samples? Yep, because it says the length is 303, which is way more than 50. But if you didn't, you'd have to get more data. So are we predicting a category? Yes. So category is basically like one thing or another. Do we have labeled data? Yes. Do we have less than 100k samples? Definitely. So the first thing it says here is linear CVC. SVC, sorry. So let's just put some markdown here. So I'm just going to write, you don't have to write this, but I'm going to write consulting the map, and it suggests linear CSV. So I'll just write that, linear SVC. I don't know why I say CSV, it's quite catchy. So now that we have written that, we have to do very similarly what we did to this, but we're not going to copy and paste that, we're going to write it again. So let's write our comments. So import the linear SVC estimator class. Okay, so we're going to import that. So we have to say, actually, what we're going to do, I'm not going to write that straight away. So what we have to do is we have to click on the model, okay? So here it says SVC, new SVC, and linear SVC are classes capable of performing binary and multi-class classification on a dataset. So we want to obviously go to linear SVC. So now that we have done that, let's go to the code. So here it says from Scikit-Learn.svm import linear CSV. So we're going to write that. So we're going to say from Scikit-Learn.svm import linear SVC. So now what we have to do is we're going to have to set a random seed just to keep everything level. So we're just going to say np.random.seed, and we'll just go with the number 42 as always. And then after that we have to make the data. We've had a lot of practice on this already, so it shouldn't be too hard. So x, so the x is all of these columns other than target, because target is our target. So we're going to say x is equal to heart disease dot drop. We're going to drop the target column, and we have to specify if it's a row or column. So we're going to say axis is equal to 1, because so the computer knows it's a column. And then we're going to say y is equal to heart disease, and simply we can just index that column. So now that we have done that, we always have to split it into, so we always have to split it into training and test sets. Okay, so we're just going to go xtrain. We're just going to go xtrain, xtest, capital X. So make sure it's capital X, okay? So xtrain, xtest, and then ytrain, ytest, and we're going to use train test split, okay? So x for xtrain and xtest, and y for ytrain and ytest, and then you have to pass in the test size. So this is the size for the test sets, and this is 0.2, so 20% of the whole data set. So now we have to actually instantiate the model. So like make it and fit the data to it. So we're just going to write here instantiate the linear SVC model. There we go. So we're just going to go CLF. So that basically means classification model. But usually you'd put model, but we're just going to put CLF to keep it clear. So CLF is equal to linear SVC bracket, and then we're going to put CLF.fit clf.fit, and then we're going to fit it to X train and Y train. And now that we have done that, we have to score the model on test data. So now that we have done, so we're going to obviously go clf.score, and we're going to pass in X test and Y test. So now we're going to run this, and overall that is a pretty good score. Okay, so it has given us an error, and it's saying liblinear failed to converge. So this is not an error, actually, it's a warning. So liblinear failed to converge, increase the number of iterations. So to do that, we can go max iter is equal to 10,000. Okay, and it will still give us the error, the warning. But what you want to do is, so this warning isn't completely stopping your output, but it's just saying to increase the number of iterations. So it will keep on saying this until it's satisfied, but don't worry about it right now. So now what you want to do is, let's just consider a consequence. What if this gave a really low mark? Because sometimes some models can give different sorts of outputs on their score depending on the dataset. So we might want to choose a better model. So if we just go back, so what we're going to do now is, here we've got linear CSV. Here it says text data, so we don't really know what that is. So because we don't know what that is, we're going to jump to Ensembl Classifiers. So in the previous video, we went to Ensembl Regressors, and it gave us a really accurate score. So we're going to go to Ensembl Classifiers to see if it can give us the same score. Okay, so here in this bit it says forests of randomized trees. So we're going to be using one we have already used before, and we're just going to look at the difference between the outputs. So here it says from Scikit-Learn.Ensembl import random forest classifier. So let's use random forest classifier now. So what we're going to do is we're just going to say as a comment, import the random forest classifier. So let's just rewrite the code that you saw on the site. So from Scikit-Learn.Ensembl import random forest classifier. So now we just need to do exactly the same steps we did before. So what we can basically do is we can just copy all of this again. So let's just quickly do that. There we go. So now that we have done that, what we can do is so now that we've done that, we just need to let's change the comments a bit. So here it says linear CSV, we'll just write random forest classifier. And then we'll take away the model at the end. And here we're also going to want to put random forest classifier. And then we don't need this max iter anymore. So now that we have done that, we can actually score it now. So we're going to score it. And if we actually compare the scores, so we'll just say, so if we were to compare the scores, we can see that our linear SVC score is actually higher, and our random forest classifier model did not go as well, but the difference is actually quite very little. Okay, so here is a actual tip if you want to sort of find out which sort of models you can use, so do you want to use the Ensembl classifiers and regressors, or do you want to use the other ones like ridge regression and linear SVC? So here is the tip. So let me just write tip. So number one, if you want to use, so if you have structured data, use Ensembl methods or models. Okay, just because even if they don't go as well, they work really well, and they won't give you these errors like this, the warnings. So they won't give you those warnings. Okay, but if you have unstructured data, what you're going to want to use is deep learning or transfer learning. Okay, so we're going to look into that further in this sort of series, I should say, and yeah, so let's just end off by just viewing heart disease, so we can sort of see. So this is actually structured data. That is why I decided to jump straight away to Ensembl methods. Okay, so this is actually structured data because it's got all those columns. So structured data, I haven't explained, is actually a pandas data frame, and unstructured data is like NumPy arrays. Okay, so yeah, so that is the end of this video. So if you like this video, please like and subscribe. That would help a lot. And if you have any doubts, please comment them in the comment section below, and I will help you with those. And as always, thanks for watching this video, and yeah, I guess that's it. Bye.